Hello, my dear students. This is Prakash Kumar Das, TGT Mathematics of J.N.V. Angul, Odisha. Once again, welcome you to the Triangle chapter of Standard 10, belonging chapter number 6. Today, we'll discuss the Converse Basic Proportionality Theorem, that is Theorem 6.2. Now, before going to discuss what is the theorem, you should well understand, you should be well known regarding the theorem and its converse. Now you see, in a theorem, one thing is given, other thing is to prove. Now this given will be transferred to proof of the converse theorem, and the to proof of the original theorem will be transferred to the given of the converse theorem. You look at the flow chart here. All of you know the basic proportionality theorem, that is, in a triangle ABC, if D is parallel to BC, that is given, D is parallel to BC, then we need to prove AD by BD is equal to AE by CE. Now you see, for its converse, this to proof of original theorem, AD by BD is equal to AE by CE, that will be going to the given of the converse theorem. And in the same way, the given of original theorem, that is, if D is parallel to BC, that will be going to the to proof of the converse theorem. Okay, so here in the converse theorem, you see, it will be telling that if this ratio AD by BD is equal to AE by CE, then you prove that DE will be parallel to BC. Now let us discuss. No need to remember the statement of the theorem. You should define a statement of the theorem from this ratio only. You see how you write this statement. It is given AD by BD is equal to AE by CE. Now who make this ratio same? Question arises, who make this ratio same? A line DE is making the ratio same. So your statement will be initiated from that concept that if a line divides two sides of a triangle in equal ratio, you see, so AD by BD is equal to AE by CE means what? If a line divides two sides of a triangle in equal ratio. To prove DE parallel to BC, who make this ratio same? DE makes the ratio same. Therefore, you prove that line is parallel to the third side of the triangle. This is the simple statement of the theorem. I can once again recite the statement. You listen. If a line, you see, divides two sides of a triangle in same ratio, then the line is parallel to the third side. So this is the statement of the theorem. Now, before going to explain the other steps like your given to proof or the proof part, let us discuss what prerequisite knowledge that must be in your brain so that this theorem will be easy for you to prove. So dear students, the prerequisite knowledge depends upon the nature of proof. Generally what happens, some proof of theorems are related to these three headings. One is your activity proof, another is your analytical proof, and third one is your logical proof. When you will go to the higher class, many of the mathematical concepts, you will be dealing with the logical proof. I can cite you one of the logical proof, that is your method of induction, or here it is written proof by reduction. Okay, so in this way, the logical proofs are generally sometimes using in the mathematical, for proving of the mathematical concepts. Now, what is this proof by contradiction? You should have to learn, you should have to know what is a contradiction proof. If you don't have idea about a contradiction proof, then this proof may be a difficult one for you to understand. Then let me explain you what is a proof of contradiction. I can tell you the steps. Dear students, you might know in the real number, in the chapter real number, a contradiction proof is there. I have to again tell you or take you to the real number chapter. I will compare this proof with this theorem, then you can easily understand it. You see, in the contradiction proof, what happened? The first step is you assume the negation of the original statement, okay, to be true with a definite condition. You remember the concept. Prove that root 2 is an irrational number. What is the nature of solving that? You remember, we are assuming that, let us assume root 2 is a rational number, which is a negative statement or a negation of your original statement. With a proper condition, what condition you have taken there? Let us assume root 2 is a rational number such that root 2 is expressed as p by q, p and q are co-prime. This is your condition. In the same style, here when you will prove the theorem here, we will assume a certain thing with respect to a particular condition. That I will say you what thing we will assume. The next thing is justify the assumption with certain mathematical arguments till you reach an absurd statement. Then if you are assuming certain things, then you justify it by doing certain mathematical argument. What is this mathematical argument is there? The mathematical argument is nothing but what? Do certain mathematical calculations. What you are assuming. Okay. Now, when you will do certain mathematical calculation, then you will definitely reach to absurd answer. What is called here absurd answer? Absurd answer means that may not be mathematically proved. For example, I can say you, if anyone is telling that whether 1 is equal to 2, this is an absurd answer. It's not possible in mathematics. Okay. Now, then the third, stop the mathematical calculation or the argument after getting the absurd answer, okay, or the relation, and justify it why this is impossible. Okay. So when you are getting that absurd answer, at that moment you stop your mathematical calculations and then try to justify why this impossible thing or impossible matter is obtained. Now, the last step is write the conclusion that it contradicts our above assumption. Hence, what you are assuming, that is not true, but its converse is true. So these are the steps of the what? These are the steps of the contradiction proof. Now, let us resemble. I can also take you again. When you are proving root 2 is an irrational number, you are taking that condition, value of a and b are co-prime. After doing certain calculation, you have seen that you are taken the condition, but the condition is coming opposite. Okay, there you are getting a and b have common factor 2. Here you have taken the condition a and b have common factor 1. So that contradicts the assumption. In the same way, here when you will get the absurd things, then you just come to the back. What we are assuming that is wrong, hence this is correct. Okay. Now let us go to the original theorem. Taking this into consideration, we will have to prove the converse basic proportionality theorem. Now we will be started with the writing part. Started with the statement, then given, then to prove, then the proof part. Now you see, this is the statement we have already discussed. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Okay. Now, what is given here? You just see what is given here. Now you see in a triangle ABC. In a triangle ABC, line DE intersecting AB at D and AC at E, such that this ratio is coming same, that is AD by BD is equal to AE by CE. Okay. Now, what to prove here? We need to prove here the line DE is parallel to BC. Now you see in this triangle, I can draw the triangle for you. That is ABC is your triangle, and here the relation AD by BD is equal to AE by CE given. Okay. Now you see we need to prove D is parallel to VC. Now you see. Now let us come to the proof part. Okay. What you see now, we are assuming. Come to that contradiction proof. What we will assume? We will assume the negation of the statement. Actually what? We have to prove D is parallel to VC. But let us assume the negation. What? If possible, assume that DE is not parallel to VC. Then there will exist another line parallel to VC. This is the condition. We are assuming that DE is not parallel to BC. With certain condition we are taking, then there must be another line parallel to BC. Say DF is parallel to BC. You see, I have drawn here another line DF that is parallel to VC. Okay, so you see, so this is your assumption part. We have assumed that DE is not parallel to VC, but another line DF is parallel to VC. This is your assumption. Then if you assume this, you justify your assumption by doing certain mathematical calculation. Let us go for the mathematical calculation. You see, since DF is parallel to VC, applying the basic proportionality theorem, we are telling that DF is parallel to VC. If DF is parallel to VC, then by applying your BPT, that is your basic proportionality theorem, what I can write here? AD upon BD is equal to here AF upon FC. Let it be equation 1. Okay, let it be equation 1. But it is given to us in the theorem that what? AD by BD is equal to AE by C. So I can write here, it is given that AD by BD is equal to AE by C. It is given in the theorem. It will be equation 2. Now you compare the equation 1 and 2 here. After comparing the equation 1 and 2, you see the LHS part of the both of the equation becoming same. So the RHS part will also be equal. Then we are getting the relation. What relation we are getting here? That is the RHS side AF by FC is equal to AE by CE. Okay. We are getting the relation AF by FC is equal to AE by CE. Then I am telling you the contradiction proof. You see, first we are assuming something. To justify your assumption, now we are in the second step, that is we are doing certain mathematical calculation to justify our assumption. Now, one of your Euclid axiom. Okay? What is that axiom? When equals are added to equals, then the whole will also be equal. Is that clear? So here I have added 1 to both sides, AF by FC plus 1 is equal to AE by CE plus 1. Okay. Now here you see AF by FC plus 1 is equal to AE by CE plus 1. Then by taking the LCM, you see AF plus FC by FC is equal to AE plus CE by CE. Then by adding AF plus FC, you can look the figure here. What you are getting here, that is AF by FC. Here you see AF by FC is nothing but your total AC. So here AC by FC, and here is the same also, A then SC by CE. Is that clear? Now cancelling AC, the numerator, we are getting the relation FC is equal to CE. Just concentrate here. After solving this, we are getting the relation FC is equal to CE. Now this is the absurd answer. The third part, you see, I am telling you, when you are doing certain mathematical calculation, you definitely get a step that is called as your absurd answer. Now all of you look at the diagram. Can this line FC will be equal to CE here? This is a bigger line. According to the diagram, this is a bigger line and this is a smaller line. Then how these two will be equal? And this is your absurd answer. Then here you stop. Your mathematical calculation, your mathematical argument is stopped here. Then you just write, you just compare why this is possible, or why this absurd answer is coming. Here I can write here, but it is impossible. So how this will be possible? This will be only possible when F and E both will coincide. F and E both will coincide. Then there your DF line will also coincide with your DE line. So then my question is, you are getting an absurd answer because you are assuming a wrong thing. Are you getting the point? Therefore, at last you write in the form of conclusion, that is, hence it contradicts our above assumption that DE is not parallel to BC. We are assuming that DE is not parallel to BC, but this will not be true. Okay? Hence, DE is also parallel to BC, that is DE parallel to BC. So this is the proof of this theorem. Thank you. If you like this theorem, please like, share and subscribe my channel Clear the Concept with PK Das. Once again, thank you.